Hello, my name is Maddox, and this is my Lab 3 Black Hole in Orbits. A little intro. In part 1, we had a star with a set mass and trajectory, and we are trying to use its orbit around a black hole to calculate the mass of the black hole. And we do this through a GlowScript program. And in part 2, we created a model in which a spaceship continuously orbits around a star and a moon without crashing into either one. And we did this by modeling all of the forces in GlowScript of FNet, FPerp, and FParallel, and finding a suitable initial velocity for the spaceship. And this lab demonstrates the effects of Newton's second law and its relationship with momentum. Intro continued. For part 1, we did end up determining the mass of the black hole, I spelled that wrong, to be around 9.09 times 10 to the 33rd kilograms. And for part 2, we successfully found a velocity that gives a spaceship uninterrupted motion around the star and the planet. Part 1, the mass of the black hole. These are the two equations that we use to base all of our code. And here's the code. As you can see, in the beginning, we have a set number for the gravitational constant, the star's mass, our time interval, and then in the two other pictures, we model the code for dp dt and all of the FNets. And then our seed was based on our RGC email, and so I used that there. The results, as you can see, the star moved around the black hole, and these are values for FNet. And then we had a bunch of values for the mass of the black hole, and we averaged them and found the mass of the black hole to be 9.09 times 10 to the 33rd kilograms. Part 2, about orbits. This was our code. And then the results, as you can see, the spaceship modeled by the purple line traveled in numerous circles around the star and the moon without crashing into either one. Some possible errors. We assumed that there were no other forces acting on our systems besides the ones included in the programs, and we used trial and error we used trial and error except for doing calculations to find an appropriate initial velocity for part 2. Our discussion. First one, what does it mean? How is the net force and its parallel perpendicular components different from the rate of change of momentum and its components? And Fnet equals dp dt, and so mathematically they are the same. However, rate of change of momentum is easier to measure because you just need to know the system's change in velocity or motion. And then what initial velocity does the spaceship need to orbit around the black hole? This was the closest velocity we could find that gave the spaceship perfect circular motion around the black hole. And yeah, that's it. Thank you.